We are going to figure out what is the ionic formula of the compound formed between calcium and chlorine. We know that a metal will lose electrons to have a positive charge, and a nonmetal will gain electrons and gain a negative charge. Specifically, we can use the periodic table trends handout to find that since calcium is in group 2, it will have a 2 plus charge, that'll be our cation, and the nonmetal chlorine is in group 7, so from that handout we find that it has a 1 minus charge. Now, here is where we can use the number swap rule. To find the number of chlorines in the formula, take the number from the charge on calcium, and to find the number of calciums in the formula, take the number from the charge on chlorine. So the numbers kind of swap, whatever's on the top goes down to the bottom on the other one. So when we write out the actual formula, there's just going to be one Ca, one calcium because of this 1 up here in the chlorine, so we don't actually have to write 1 down here, although, oops, I just wrote it. In the chlorine, there are going to be 2 of them, so we write the 2, which came from the 2 plus on the calcium. So when you look at the formula of an ionic compound, that formula should be neutral, and that's why the number swap rule works. In an ionic crystal lattice, the formula unit, which here is just NaCl, so a negative and a positive, has to be neutral, because if it wasn't, its charge would get repeated again and again and again throughout the ionic lattice. So if we take a big chunk of crystal, it should be neutral. It shouldn't, have a big charge accumulated on it. So the way for the big chunk to be neutral is for the formula itself to be neutral. So we have 2 negative chlorines here for a 2 minus total from the chlorines, and this 1 calcium is a 2 plus. So the 2 plus cancels out the 2 minus over here. Here is a more complicated example where we might actually have to do the number swap rule to find the formula. This is an ionic compound formed between barium and the polyatomic anion phosphate, which has a 3 minus charge. So here, let's do the number swap. The number 2 comes from barium on the top and goes down to the bottom of the phosphate, and this means there's 2 whole phosphates, not just the oxygen, but the whole PO4 3 minus. And then the 3 minus from the phosphate comes from the top right down to the bottom left, meaning that there's going to be 3 bariums in the formula for barium phosphate. And when we write out that formula, it'll be Ba3, PO4, 2. We have to put parentheses to show that there's 2 of these units of PO4. The P and the 4 oxygens stick together.
Made with Doodlecast Pro.